you know, nothing could be more fitting or more satisfying than having Michael do the introduction, because the whole point of being a teacher is seeing what happens in future generations. And the fact that I was able to teach him when he was an undergraduate here, and now he's taking over, right? It's just a great thing to see happening. So, as Michael pointed out, the motivation I had to put together this particular talk was the award speech for the Research Achievement Award at CHI a couple of years ago. And what that gave me is license to sort of look back, right? It's usually you give a talk and it's here's the latest stuff that's going on. But then when you get old enough and gray enough, you get the license to say, hey, look at all this. And it was really fun putting it all together because it really made me aware of how much great work had been done over the years in HCI. I mean, a lot of the stuff that seems really new and fresh now, you can go back and see the roots of it 20, 30, 40 years ago. What you'll see here, I collected up a bunch of pictures and stuff of the oldies but goodies, right? I mean, things that have been around for a long time and still have a lot of value. So the structure, I'm going to talk some about, did I just, no. The history, but the context for that is looking at how things have progressed in the different dimensions that go into the name CHI. And as you know, we here call it HCI, but the ACM many years ago created a special interest group in CHI. The question is, are computers first or are people first? We believe people are first, but that's the way it's been. It's a much catchier acronym anyway. CHI is a Greek letter. Hickey is the wrong acronym, right? There's computers, there's humans, and there's the interaction. So I sort of started with that as a framework for looking at what went on. So assuming, let's see, I probably have to get my cursor somewhere else. There we go. So how long have computers been around? All right, and this is actually a test for you gray hairs in the audience. I'm going to ask recognition. Who knows what this is? Okay, lots of people. Somebody say.
Babbage.
This is Babbage difference engine. This is not Babbage. That's Doran Swade from the Science Museum in London, who put together a working model of the Babbage. I think this is actually the original engine, not the fancier one that he was trying to build. But computing has been around in some form or another for, what is that now, 150, 100, getting close to 100, well over 100 years. So the idea's been around, but of course it didn't take hold until we had electronics that could make something that was not as cranky and hard to deal with as a big bunch of gears. So test number 2, who's this?
Grace
Martin, who was one of the primary movers in the use, she was actually an admiral in the Navy, of computers. This is now back in starting World War II, when computers started to be used in a very practical way. Of course, it had always been used for these kinds of purposes. I mean, the stuff Babbage did was for calculating tides and moving navies around and stuff. But the use of computers became much more effective and broader. This is a UNIVAC, one of the early computers. And what's interesting is, of course, in those days, all computers were personal, right? You sat in front of the thing and you pushed the buttons. That's how you made it run. So that was the original idea of computers. I got into computers in some sense back in the early 1960s, early 1960s, maybe even late 50s, with this computer. The guy with the short hair is actually me. And this was my high school science project, which was a sort of hybrid digital analog computer. What the digital meant is these dials actually had fixed positions, and the analog meant everything was done by having a whole bunch of resistors that you measured the currents on, and they came up on the dial and stuff. Interesting point that I did this when I said my high school science project, went to the science fair, and the judges said, gee, that's really cool, but it's engineering, not science.
And I think CS has been fighting that question ever since, right? Do we really use science? Is it really computer science? Or is it just, of course, that's a funny word, engineering? The guy who won the science fair had a thing where he took fruit flies and did some experiments on them and stuff. You know, it was real science. A few years later, around that same time, this is what a computer looked like. Right? So the hardware had become much more regularized, much more industrialized. It sat behind glass windows in a big room. People sat and ran operations and did all the stuff with those big tapes and stuff. My first contact with digital computing was a slightly different interface. I wasn't sitting in the big glass room. How many of you know what this thing is?
Okay, how many have ever used it? Okay, that's the real gray hair test. That is, the way you input and output things to the computer was by taking some kind of a material, paper, or in this case, Mylar was actually used, and punching holes in it which could be sensed, and then feeding it into the computer. So when I started teaching here in '73, the introductory programming class punched decks of cards and took them over to the computer center and submitted them in a window, and then a while later we get a printout saying that didn't work, and then they go back and do it again and again. The first computer that I used, which I'll show you in a minute, had paper tape, which was a somewhat, well, just a different format, but the same basic idea. It was this machine. How many now, who are really test, how many know what this machine is?
Might be a 1620.
Nope, wrong company. So this is made by Control Data. Now, your first reaction is, wait a minute, I thought Control Data made supercomputers, Cray and all that kind of stuff. The answer is yes, but in the early days they did a variety of things, including the 640, number right, which was a personal computer. This actually, the size factor here is what it looks like. This is a desk, right? You put your knees under here, you got a console there, you punch the buttons on the console. It has a paper tape reader, which you can see in the upper right there, which takes in those reels of tape that I mentioned, and a paper tape printer, which actually came out the left-hand side here, which printed out, punched out tape. And the way you interacted with that is something called a flexowriter, which was like a typewriter that punched and read paper tape. So you'd type your stuff on the flexowriter, you'd run the tape in. My first experience with that, I actually had one of these at the college I went to during a special workshop. There was no such thing as computers in colleges in those days. It was a small college. And it was a very hot day, and so in order to keep the computer running, they had to put a fan behind it. And of course, I managed almost immediately to run an entire reel of paper tape directly into the fan. So learning about atoms and bits from early era. From the point of view of my own sense of human-computer interaction, I think it's true these things have a big effect. The important point about this was it was my personal computer. There's a guy who got a position in the town I was in who had previously been in a bigger city. He came with this computer which he'd gotten on a medical grant. He was actually calculating things for radiation treatment of cancer. And he called up the college and he said, do you have any computer students? And they said, computer, what's that? All right. He said, well, do you have any math students who might be able to figure this thing out? So I got a job. I would go over to the hospital after school or at night and sit in a room with this thing and program. Okay, and I didn't know anything. I mean, literally, I had to reinvent assembly code in some sense because all I had was the numerical machine manual. But what it gave is the feeling that a computer is not something that sits in a glass cage and you submit decks to, but a computer is something you push the buttons. Actually, the repair person said, I don't know why the buttons on this computer always seem to break down. The answer is that's how I was programming. It was much more effective than punching tape, so I could push all the buttons. So this is a more or less contemporaneous 60s computer. Now, I know some of you know who this is. Joe Weisenbaum, who was at MIT. This is a Model 35, I believe, teletype that he was using, which was the way you communicate with computers, one step better than paper, tape, and punch. And I'm going to come back later to talk about ELIZA and what he did with it. But when I got to MIT, now we're in the mid-60s, this was sort of the state of the art in what people were using in computing. You could interact with it by typing on a teletype. There were the original time-sharing systems have been developed. John McCarthy, who unfortunately died recently, who was here, was one of the, obviously, the founders of that and was at MIT for a while. And
there was a chance for people to have a direct, immediate interaction with a computer, even though they didn't have one dedicated to themselves in a room in the hospital. Jumping ahead, this is a bit later, okay, and anybody who's gotten a degree here in HCI should recognize this one. Okay, this is
Zero star.
the Xerox Star. It's actually, no, it's not.
The sun.
If you look at the screen, this is an Alto screen, not a Star screen.
So this is the Xerox Alto. This was the beginning of the shift in how you think of what a computer is. Right? It was the first graphic screen that was done. It was the first attempt to let you interact with a mouse and do things on a personal computer. I'll come back to Engelbart and the mouse in a minute. And in some sense, everything we have done since, so we're now talking, this was in the early 80s, so it's 30 plus years, has been variations on that theme. We're moving beyond, we'll talk about that, but that, it's what? Mid-70s, sorry, mid-70s, yeah. So this is, really what's interesting about this is how stable this configuration, this way of looking at things. If you look at this and you said, this is something I bought recently, most people wouldn't know. They look a little weird, but it's more or less what you can still buy from Dell, right? It's the same thing. I'm not picking on Dell, just, it's not a tablet, right? So I was at Park, actually, with Danny Bobrow, who's here, and a number of people for years, including Alan Kay, who I'll talk about also. And they really had a whole thrust. Actually, tomorrow night, probably not relevant to most of you, but at the Computer History Museum is having their annual honoring of new fellows. And one of those new fellows is Bob Taylor, who was the head of the lab that did this at Park and was really a visionary back in those very early days in the 70s and sort of moving from the whole mainframe mentality to the personal computer mentality. He wasn't himself the guy who built it, but he really collected and pushed and made resources to make it happen. At around the same time, this guy was doing work across town. Who he is, you all know him. Engelbart was at SRI, which at the time was Stanford Research Institute, and he had a system they called Augment, which was, or called NLS at the time, various names, but which enabled groups of people to work together. It was very consciously a shared system, not a personal system. The Alto was personal with networking. This was really a shared system. And he invented all sorts of things, which again, if you went to the store today, is not that different than what he did. So he is the original creator, you can't see it in this picture very well, creator of the mouse. He actually thought his other input invention was better, and was always somewhat frustrated that people didn't pick up on it, which was a keyboard you can use with one hand by hitting down multiple keys at once. Because his view was you wanted to keep one hand on the mouse, one hand on the keyboard, and not have to keep shifting back and forth. Right? But it turned out this was too hard to use. The mouse was really easy to use. It became the main source. This picture actually comes from an event that was held in San Francisco back in 1967, which is known colloquially as the mother of all demos. And it's really pretty impressive. You should look at the video. There's a YouTube that you can get. Look up Engelbart or mother of all demos or whatever. They set up this is in a big hall in San Francisco, a projector. Okay, now today the projector up there is, okay, you put a few $100, you get a projector. In those days, it was an incredible technical tour de force to have a projector that could actually put stuff on a screen in an auditorium from a computer. It involved writing in oil and all sorts of amazing stuff. He then set up a microwave link to connect that to his lab back in Menlo Park, which again, today is nothing. In those days, the idea that you could have a computer in Menlo Park projecting on a screen in San Francisco that's the future. He had a video conference, so along that link, he was on video here. Somebody tell me the name on the other end.
Bill English?
No, it wasn't Bill. It was, I'll get back. I remember, right? Anyway, was there, and they were talking as they were doing the typing. So they had Skype, right? It wasn't quite Skype, but it was there. But that whole texture, that feel of what it's like to compute on the network, to type things in, have them show up on the screen. This is also interactive in the obvious way. It was an outliner. So if you look up there, you'll see it's a grocery list, which he uses for example, and you could add things and move them around and reorder them and sort them and do all the things which, again, today seem completely of course. In those days were just like amazing that a computer could do those things. It wasn't what people thought about. They thought about computers as calculating numbers, right? That's what they're good at. At the same time at Park, and I'm a little Park-centric because I think they did amazing, a lot of the early work in all these areas. I was not involved in these particular projects, but was around and sort of seeing what went on. Who's this? The guy with the suspenders? Mark Weiser. So he had a group at Park that was developing what they called ubiquitous computing. And his idea was you didn't want to think of a computer as just that thing on the desk, but it should be all different scales. So he talked about computing by the inch, the foot, and the yard. So computing by the inch was this thing called the Park Tab, which you see up at the top, which wasn't quite as sophisticated as an iPhone, but was the ancestor. An the iTab, the iPad, and the, what was the this wasn't called the iWall. It had some other name. Anyway, it wasn't called right? It was, sorry, the Park Tab, the Park Pad, and the Park something. But again, when you look at this and you say, well, isn't it nice to have a tablet that you can actually pick up and write on like a tablet? Nice to have something up on the wall that you can actually scribble on with markers and it knows that you're scribbling on. That's pretty much what people are using. I mean, that's very much part of today's culture. This was now back in the early 80s, or late 80s for Weiser. So the technology moved beyond the sort of computer as a simple form factor to this ubiquitous concept. We did some work on that here at Stanford. So this is something called the iRoom, which is just about 10 yards down the hall here on your left, where we tried using multiple big screens, a table-based display, integrating it with so the stuff on your laptop could be combined with the stuff that was on the screen. Francois Gambetrier, who was a student who worked on how could you have high-resolution, up-close interaction with complex visual materials. So this is all part of that same development, and going back to my sort of framework, how you rethink as you go along, what is the computer that you're using? Now, today you think about phone-size things, smartphones, and so on. So obviously this has progressed, but in some sense those directions were set up. So I want to switch gears and think about the second component, which is what is the human? And I'm posing this as that question, which is sort of an interesting way to ask, what is it to be human? Well, let's take a first most obvious example. A human is a physical bunch of protoplasm, right? A human is somebody who has a certain figure, a certain size, a certain shape. And this view of what it is to be human actually played a big role in the early development of what later became HCI. If you go back to the literature on what's called human factors, people realized, and this is again starting with machine-human symbiosis in essentially World War II is when this all became active, that if you were going to have people use computers accurately, you needed to at least conform to what people are. You couldn't build it too big, too small, too strong, whatever. And there was a whole field of World War II research in human factors, which was basically looking at the human from this sort of what are the human physical capacities side. This picture actually is not from that era, it's slightly before. It's from work by Henry Dreyfus, who was a very early industrial designer. Fascinating guy. He, I have his book title in here somewhere later, but who actually started out in stage lighting and things like that. He was a designer, got into industrial design, then got into sort of industrial design from a use perspective, designed things like the train from Chicago to New York, where he was involved in everything from what it looked like inside the train cars to how did you get your tickets. So if you think about interaction design, he really was one of the founders, along with Raymond Loewy and some other people, of what became the design world, the industrial design later on. Okay, so it's clear that a person, among other things, is a physical body. If you want to understand that, there are various fields that help you understand it. So human factors sort of tries to condense the stuff from physiology and physics and so on. What else is a human? Okay, who's this guy? Alan Turing, right? So Alan Turing, among many other things, is famous for having said, I will believe that a computer is like a person when it can carry on a conversation with me. Okay, so this is now back in the 50s. And he said, this is the famous Turing test. The measure of humanness is the ability to carry on not a necessarily verbal conversation, it could be typewritten, but a conversation in ordinary language. And this has become, over time, of course, in many ways, a measure of what's human. So who's that? Hal, right? For those of you who are young and haven't seen it, go see the movie. It's 2001, which is now long in the past, but still haven't quite gotten there yet. Hal was a computer system on the spaceship who interacted with natural language. The interesting thing about it is there was no attempt at personification or robot or anything. Hal was this blinking light, but talked like a person, right? And there was a very strong sense that he was he, and it's almost impossible not to call him a he, as opposed to, because the voice was a male voice, was a person who sabotaged missions, so on and so on. There's a whole wonderful plot that went into that. So a second view is that a person, what it means to be human is measured by whether you can use language. Okay, now this was followed up by various programs. So I mentioned earlier Joe Weisenbaum. I showed you a picture of him. He wrote a program called ELIZA. How many of you have actually interacted at some form with ELIZA or the doctor? It has different names, right? It's around. You should go find it on the web. It's now the kind of thing you could give a freshman, a couple hours to program. I mean, it's not sophisticated by today's standard, but it was very sophisticated. Yeah, right. ELIZA let you type in things and you type back. So you typed, are you like my father in some ways? And ELIZA typed back, what resemblance do you see? And it says, you are not very aggressive, what makes you think I am not very aggressive? Okay? Now, what's interesting about ELIZA, and it's a really important lesson for this whole question of what it is to be a computer and a human, is it showed beyond doubt the power of projecting intelligence onto the things we used. So ELIZA was a really dumb program, right? So for example, it had rules that scanned the text. So if it saw the word mother, it said, tell me more about your family. Okay? So if you said something like, my friend's mother just died, it says, tell me more about your family. Now, if it was a person, you would say, that's crazy, right? But because it was pretending to be a psychiatrist, which was an incredibly clever trick of Weisenbaum's, your first thought was, oh, that's interesting. I'm sure my friend's mother dying has evoked all sorts of feelings in myself about my family, and it's really a smart thing to ask, and right? You build in the intelligence. You project back the intelligence because it's responding like a person. A lot of you here have taken classes from or read books by Cliff Nass and Byron Reeves on what they call the media equation, and it makes that point in many, many ways, that when we interact with a device, which in even the slightest sense is person-like, we make it much more person-like in the way we react to it. And it's probably, from an evolutionary point of view, a pretty good reaction that we have, which is to treat people differently from the rest of the world. But it does do funny things in cases like this. So ELIZA was a great proof that you don't need to really be intelligent, you don't need to really use language to make people have the feeling that you are. A little bit later, I did a program which got a lot of note called Sherdlu. This is a picture from the screen. And it was based on work that was going on at the MIT AI lab, which involved trying to get computers to do really simple things that kids can do. So there was vision, trying to look at a scene with a bunch of blocks and figure out what's in it. There was motor, a simple robot that was trying to move them around. And there was simple language. It got called the blocks world. And I took that as a basis for what could you actually achieve in getting a person and a computer to work together using language. So you would type in something like pick up a big red block. And what you would see on the screen, notice this is before the days of hidden line elimination and sophisticated graphics. What you would see on the screen was that sort of crane-like thing come down and move it around. Okay, the interesting thing about it was two things, I think, that made it have a significance. One is that it was integrated with a model, a logical model of what was on the table. It actually had a record of where are all these blocks and what color are they and so on. Notice the colors, by the way, this is also before the date of color screens. They're little, it says red here in small letters. Right? Second is that in building it, I was paying attention to linguistic details of things like context. So one of the most obvious points about human language as opposed to formal languages is that we only say the minimal part of what we need to say, given that we know the other side is understanding. So consider a phrase like, pick up a bigger one. What does that mean? What's a bigger one? Bigger than what? And so on. Well, the answer is obvious, because you just said pick up something, and in fact, I probably mean the one you actually picked up. Right? So I pick up a bigger one. It's a block bigger, not than any particular one, but the one that you just picked up. And I built into the program a bunch of these sort of heuristics, a bunch of these rules which say when somebody uses a pronoun or uses a word like one or says do it again, I mean, all these things that we just take for granted, there is information in what's gone on in the past, in the world. And because this had a complete record of what it was doing in this little toy world, it was able to come up with a response that seemed way, way more natural than anything people had done with computers, I think. Now again, let me remind you of the projection question. How much was it really smarter and how much was it just projecting on it? But in any case, it really got people to thinking, well, computers could be pretty smart in the Turing sense, right? In the sense of making you feel like you're interacting with a real person. I wrote a book on this, which published actually originally by Edinburgh University Press, surprisingly enough. This is not the version that's around mostly. I was working in the MIT AI lab, and there's a couple, in addition to the fact that my hair was just as big but different color. There's what you see up there on the left. Anybody? Any gray hairs on that one? DEC 360 display, Digital Equipment Corporation with micro tapes. Okay, a whole bunch of interesting sort of technologies that Digital developed in its heyday of being a real computer company. And this is Marvin Minsky, who was the head of the lab and was looking at all these questions like how could you have computers with arms and vision and so on. This is an arm he designed with the idea you don't need to have the same joints people do. You need the same number of degrees of freedom to get to where you want to go, and that maybe there are very different ways of doing that. He actually advised, he was a technical advisor for the 2001 movie on how you could do things interesting ways. In today's world, this language is still considered a measure of intelligence. What is the question to this answer? Who is Watson, right? So putting it in this perverted Jeopardy direction. There was a program that got a lot of notice within the past couple of years because it defeated a human champion at trivia questions. Okay, and I'm using trivia questions here in a somewhat technical, not pejorative sense. That is not questions like, what is the most important meaning of whatever. It's like, what battle of so-and-so did such and such win in, so on. It's questions which can be answered with a fairly straightforward application of direct bits of knowledge that you can find somewhere out in the digitized knowledge of the world, right? So I think we're very much still in this sort of view that being human, here's a picture of him. Interesting, I just had this discussion with somebody about the fact that IBM chose very consciously not to make it a human-like face. Right? Notice this could have been a cartoon, it could have been a picture of a person, and instead they have this very abstract icon. I think people would have very different psychological reactions in a way if they had. So, let me move on. We'll come back to natural language if you want, but the basic point is that one of the things that really categorizes people is their ability to use language, and of course, there's a lot of study in linguistics. A lot of what I did was based on linguistics. A lot of what Watson does is based on linguistics. And what I'm doing with this right-hand column here is just pointing out that HCI is truly interdisciplinary. If you want to do research, you want to build things, the key is that you need to bring in all of these different fields. It's not like there's just one that tells you what to do. Okay, so here's another model of what the brain is. What's his name? Bubblehead, right. So Bubblehead was a conception of how people think that was done by among others, Al Newell and Herb Simon at Carnegie Mellon, people like Tom Moran, who was at Xerox PARC, actually. Everything, all roads come back to PARC. And the idea is, in a way, going back to that Dreyfus thing, but in the head. So if a person is able to reach 3 feet out, but not 4 feet out, that tells you something about human capacities. They said, well, that's also true for the way you think. So if I do the most obvious experiment, most of you have done this, but just for completeness, repeat after me. 4302. 71968. 507-362-485-222. What George Miller discovered in the 1950s was that your ability to do that is extremely regular compared to most other people. It's not like you can remember 3 and he can remember 8 and he can remember 12. There are a few exceptions, but within the great majority, everybody basically runs out of steam at what number? 7 plus or minus 2. Okay, it's the name of his famous paper. That is, we're just geared, we're just built to be able to remember about 7 numbers. That's why telephone numbers are about that long, among other things, right? It's not because we've used telephone numbers. That's why they built them that way. Right? So in the same sense that Dreyfus could talk about the physical characteristics, we can talk about the mental capacities. How much can you remember? How long can you remember it? How well can you perceive differences? Don Norman, who's here, did a lot of the early work in sort of looking at a whole bunch of different dimensions of these kinds of questions. So from this point of view, a person is a cognitive processor. They have a long-term memory, a short-term memory. They have a set of algorithms for going through data. And the obvious metaphor here is the digital computer. If I were to say, here's a computer, and if you give it 5 numbers, it restores them. And when you give it 6, it can't. You say, it's got a 5-number register. Right? The notion of a register of fixed length is sort of just a natural thing that flows out of a digital model of storage and memory. Maybe there were things like this that were the same kind of digital model. So another way of looking at it is that a human is an information processor. This led to what's called information processing psychology. It was really the roots of a lot of what's gone on in HCI. Here's a picture of Newell and Simon, who were the sort of pioneers of this whole approach at Carnegie. One of the things they studied was how people play chess, which was a great example of a kind of cognitive process that people could use. So this is the mental version of the human factors dimension. It says there's cognitive psychology, which can give us all sorts of insights into the human, thinking of the human as a finite fixed capacity memory or information processor. And for many years, this was a dominant paradigm in psychology. I think it's still a very active one, although I think a lot of the more explicitly neurological stuff has become much more the sort of things that people focus on now. But they're combined, right? When you look at neurons, you're still often thinking of them as how do they function as a limited capacity memory, limited capacity information processing device. Okay, back to this guy. I don't know if you see in the picture, Doug Engelbart. Okay, so this is Silicon Valley before the current dress code, where all the engineers wore white shirts and narrow ties. You can probably date it by the width of the ties. And he said, I don't think of people as these isolated entities that have brains and talk and so on. I think of them as communities. I think of them as people who work together. And what I want to do is augment their ability to work together better. So he created, among other things, that demo that I talked about earlier, the NLS system. And his whole point was, how do you facilitate this kind of interaction? I can remember very clearly when I was a graduate student at MIT in the AI lab that I showed you Marvin Minsky. And Engelbart came and gave a talk. This is late 60s. And the general reaction was, that's really stupid. Why would you want a computer to help you type things when you can make it smart? Right? If you're not making the computer be intelligent, you're wasting the computer's time to just put things on screens and type them and communicate them and that kind of stuff. We can do that on paper. So I think that was a blindness. I think it was a blindness within the AI community that said, the only interesting use of computers, the only interesting way in which they're like people or they're useful for people is to make them be smart. So Engelbart had a very different take on that, and that led into the whole field, which is often called computer-supported cooperative work, that a person is somebody in a group. And I said here, a worker in an organization. Clearly, that's what he thought. I mean, he was not looking at social networks and people with their friends and so on, but the whole world of looking at the computer as a communication device between people who are getting things done together grew out of this sort of focus on that. There is a bunch of work. I'm not going to go into details. This is my own particular piece of this, and notice each long where I'm sort of trying to hang in a little bit of what I got involved with. This is a representation that I developed along with Fernando Flores and others about the use of commitment, the importance of commitment in tracking things, getting them done, completion in work settings. We wrote a book together, which was strongly influenced by these guys, who some of you probably recognize. I will point out, since Danny Bobrow is here, that a lot of this got started back in the 80s or whenever this was, maybe even 70s, when we went, and he and I and some grad students went up and had lunch with Dreyfus and Searle at Berkeley and discussed the issues of what are computers really doing. Interestingly enough, Fernando is now, we're starting on another book together. He was in the, long story, but he was actually in the National Senate of Chile for 2 terms, has finished those terms, decided he's had enough of politics, is coming back to this country, and we're going to work on another book, which I'll be glad to talk about in a later thing. Okay, so worker from the point of view of the Winograd Flores book is a source of commitments. It's something you can study, and I threw in here management and business as kind of very broad brush labels. If you want to understand people in the business context, it's not, or in the work context, it's not about the thoughts per se, it's about the interactions. And that's what the kind of thing that field gets into. Okay, so we're going to get a couple more here. This is a real test. Anybody recognize this piece of text? In particular, its formatting. Okay, this was probably the first, if not the first, use of a computer to generate text in a font that was designed to be read as a font as opposed to the computer font. Okay, this was on what was called the Research Character Generator, which was built at Park back in the early 70s, I think, early 70s, I think. Alan Kay was the sort of driving force in it. A bunch of other people, Chuck Thacker, Bill Butler-Lampson, actually did the technology. But the idea was you would want a computer that could give you stuff to read in a way that made you able to read it well. Okay, remember again, this is before ebooks, this is before Kindle. This is just the idea that you'd have text that wasn't the thing you were talking to the computer about. Right? That, again, it seems funny to think of that as something interesting, but it was interesting in those days because every other computer interaction was about the thing you and the computer were interacting about. So there was a notion that people are information seekers and producers. This particular, is Andreas here? Now, Andreas Pepke, who's here in the Info Lab, is the one who actually is responsible for the artwork here, which I will let him defend. But what we had here at Stanford is one of a group of projects around the country on what was called digital libraries. And the idea was think about what's online as a bunch of materials that you can access and read and share and use, right? So you're focusing on the materials rather than focusing on the cognition that went into them, right? Or even the work structure. So back in those days, I mean, you'll see some interesting things here like Z3950, which most of you probably never heard of. It was a protocol for exchanging library information. And all of the things which we now think of as being, of course, that's the web, internet libraries, payments, interfaces, annotations, and so on. All right, and among other things, it being a university, we said, let's find some bright students and let them play around with this stuff. And in particular, we had a couple of bright students named Sergey and Larry who came up. This is actually a page. This is actually what the Google homepage looked like when it was still a Stanford project, not a company, and obviously before it was fully developed. But they said, and in a way, I guess this is an interesting thing. I'll go back to what I said originally about Michael, about seeing the next generation. in a way, they showed us a new world, which is the picture you saw before was based on a model which said there's a bunch of highly curated, highly developed things which are available on computers, and we want to integrate those. And they said, no, let's not worry about all, what is in LexisNexis or that kind of stuff. Let's just take anything that anybody puts on the web and index all of that. And I think my first reaction, and most people who'd done this kind of information research, was that's a bunch of junk. Why do you want to go around and collect all the junk when we have good, well-developed resources that you could be using? And they said, no, we want to collect all the junk, right? They went ahead. Larry credits me, and I have to disavow this because I don't remember it specifically, with telling him, yeah, why don't you go ahead and do this web search thing instead of some other project he was thinking of, like space tethers or whatever it was. But anyway, it's clear that this whole world shifted to thinking about people from the point of view of how they find and use information. And that the computer is a basic tool for that quest. There's a bunch of disciplines that can play a role there. And again, I put here just infoscience as a broad brush. But the obvious point is that to understand that, you're understanding the nature of the information structure. Again, going back to Park, there's been work on what's called information foraging and so on, about how you do that. Okay, a couple more. This is a really old-timer one. Anybody recognize this? Probably not, because it's not a famous picture. This gives it away a little. A photo by John Coate. John Coate was one of the original people who created something called the WELL, the Whole Earth Electronic Link, to give you the acronym. And the WELL was the beginning of social networking in some sense. The WELL was, from today's world, a sort of simple bulletin board, no interesting technology, but they created a community around it. They had people who had identities on it. They would enter discussions. People would comment on the discussions. That entire notion that the computer is providing a medium for this kind of social interaction was started not just by the WELL. There were some other early bulletin boards and so on, but they really did it. What's interesting is, first of all, they developed a community. So this actually is the first annual chili cook-off that they held, F2F, as we now say. That is, they said, this is going to be a community. It's not just a bulletin board. It's a bunch of people who know each other, who like each other. John actually gave a talk in this series, probably 20 years ago, 15 years ago, called Innkeeping on the WELL. He saw himself as an innkeeper, somebody who gave people interesting stuff, got them talking, kept out the rowdies, and so on. So the WELL was a different view of people, which today looks like this. Okay, you're not supposed to, of course, see any detail here. This is a social graph, right? It says who you are has to do with who you connect with, where connecting is what the WELL was all about. So that says a person is, in some sense, a social being. Again, if you want to ask who are the other disciplines that are relevant, you get into, among other things, sociology, anthropology, right? There's a whole set of issues about people and how they behave. And if you look at the work in HCI today, there's a much bigger component which is based in the sort of methods and understanding of these fields than back when it was mostly cognitive and how does a person remember things and so on. Okay, actually what's interesting is I don't think he still has a page like this, but he has millions. At that time, this is historic because I think there's something here where it says he has 32,000 followers. All right, how many followers does Ashton Kutcher have now? It's got to be well into the millions, right? Not a question, right? So what this says is that there's something more to social networking than just being able to get together and chat. You're not getting together with Ashton Kutcher and chatting, and he doesn't expect to and doesn't want to. There's a different kind of feeling for what happens personally to an individual by virtue of interacting in these networks. And I want to take a little detour to talk about what the meaning of that is. And I want to take a detour there about what I mean by meaning. And this is a lesson I learned from the work I've done in the D School, which I'll come back to a bit, in understanding people's needs, and needs here in a deeper sense, not just, I need a pair of glasses that works and so on. So Michael Barry has a company called Point Forward that does design, and one of his projects, which was quite successful, was he worked for Kimberly-Clark, or whichever the competitor was, and they said, we want to redesign diapers. Our competitors are catching up, we want to improve, and so on. And the way he describes it, he says that people in the company thought of diapers as waste disposal bandages, and to improve them, you made them more effective and efficient at waste disposal, right? That's the whole point of having a diaper. He went around and he interviewed, talked to parents. In this case, you don't talk to the users directly, you talk to the, although I guess I would say, in this case, the users aren't the person who has the diaper on, right? It's the parent is the user. And what he realized is that diapers have a very different meaning to parents. They're not about waste disposal, they're about growing up. That when my kid is in diapers, I have a certain feeling about who they are, what they do, and when they graduate to potty training and so on. I mean, you've all been through this. Many of you as parents, but I know all of you at least as the first time around. It is a very emotionally loaded topic, right? It's not just about, okay, can we clear off the poop with the least germs, right? So he created this whole category called pull-ups. And the motto for pull-ups, does anybody remember? I'm a big kid now. I mean, now advertisers are not subtle. Notice what this kid is wearing, right? The I'm grown up is sort of carried there as a badge, right? And what he realized is the meaning of diapers was a meaning about growing up and a meaning about kids and adults and so on, not a meaning about what you think a diaper is about when you just think directly. And that from a commercial point of view, that was a tremendous success. Right? Then all the other manufacturers imitated them and so on and so on. And now it's a whole, I don't know the numbers, but if you were in business, you could tell me how many billions of dollars worth of a category that is and so on. So the point of it is that when you think of something from a sort of functional point of view, you're only seeing that side of it unless you step back and say, what is this role does it play in people's lives? What is the meaning to their lives? So let me talk a minute about what are the different sources of meaning that people have. Okay, being grown up is one for kids. So what do people do that matters to them? Or what are they? How do they identify? What's their identity? Now, identity has been an issue on the web for sure for ages. A lot of you, I'm sure, have seen this cartoon over the years, right? The famous on the internet, nobody knows you're a dog, which plays on this notion of identity, which says that your identity on the internet is something that isn't your same physical, cognitive, and all the stuff you do, because you can create it, you can manage it. A lot of you probably read Sherry Turkle's books, The Second Self, in which she talks about all of the different ways in which issues of human identity are played out in this online world. So personalization is an example of personal identity. Who am I? How do I project? What do you think I am? You can have artificial identities. This is Hatsune Miku. Anybody know Hatsune Miku? Okay, the hipsters here do, right? So this is a famous Japanese pop star, is that right? Who happens not to be a person. Right? It's a purely online identity, but who does all the things that pop stars do by being online. This is an experiment where they had kids playing with artificial playmates. The point is, identity, individual identity is a big piece of this. There's also your social identity. And by social identity, I mean who gives you credit, appreciation for what you do. So this is actually my daughter's blog site. Blogs are a fascinating example of people putting themselves forward as a social identity. It's not who she is. I mean, something, there's part of that, but it's really, am I doing really interesting stuff that people want to know about, that they'll follow? I'll get a lot of followers, I'll get people interested. It's fame and fortune, sort of, but in a more personalized way than just how much money did I make. So I'll put fame and fortune as the thing there. There's family and friends. So a lot of my identity, now that I'm a grandfather, has to do with these two little kids, and third on the way, right? And you can read a lot of stuff that comes out about how when we really step back and say, what's my identity, what's my meaning? Those things play a very big role. The old line is, nobody ever said on their deathbed, gee, I wish I'd spent more time at the office. All right? That these things are things that for biological, evolutionary reasons are very important to people. And they play into the computer as well. This is a company that I'm on the advisory board of, started by a former student here. So a lot of you may know Tico Bayagas, worked on that iRoom thing I showed you back there a while back. And there, they built an application which is very simple. A distant grown-up, grandparent typically, or absent parent, whatever, reads to a child using two iPads. And they can see each other. They can point, and the shadow shows where the other person's finger is pointing. And say, okay, it's time for bed. Let me read you a book. So you're using the computer to intermediate this kind of connection that we think of as being direct and personal. Another is that there's a community and society. My identity, to a large extent, and everybody's, is what role am I playing? How much am I helping the world, or the world in a local sense, my church, my whatever the community is. I got involved, just to give my own personal version of this, back many years ago in something called Computer Professionals for Social Responsibility, which had a great slogan, which I still like: technology is driving the future. It's up to us to do the steering. So because of being in technology myself, the community aspect was how do we integrate these larger political community concerns with the development of technology. In the past few years, and Michael mentioned this, I've been involved with what's called the Liberation Technologies Program here at Stanford, where we have a variety of projects. We have fellows. This is a fellow you probably should know. His name is Evgeny Morozov, and he just wrote a great book called To Fix Everything, Click Here. Or to Save Everything, sorry, to Save Everything, Click Here. He's a critic of the sort of view that there are simple tech fixes to everything. So we've hosted people like him. We have courses where we get people using new technologies in simple ways that can improve their lives. Did I skip one? No. Okay, meaning. Those are all things that, not all the things. Those are a list of things which you might consider. And let me take a step back and say, if you're doing HCI, which is where this talk was originated, it was for Kai, these are things that might guide what's worth doing. What are the things you want to build? What are the things that are interesting to research? Now, from the beginning in this program, I always use the word design. You notice the seminar officially, well, I don't know what's official. It has two names, all right? If you look at the Stanford catalog, it is the Human-Computer Interaction Seminar, and every time somebody gets up to introduce it, I know you've continued this tradition, they say, welcome to the seminar on people, computers, and design, which is what it was originally titled. What's design? Well, the first I mentioned earlier, this is actually the book that I referred to by Henry Dreyfuss. What's interesting about this, again, is this is more than half a century old, but the title is Design for People. So when he was thinking about designing railway stations or whatever it was, the starting point was what we now call human-centered design. Right? How do you think about what it is for people and what they use? I wrote a book, I edited a book, had a great workshop. When I say great, I mean they got lots of interesting people to come, including Don, and is anybody else here who was at that workshop? I don't remember. Oh yeah, Sarah, right? Back in the early 90s, to ask the question of how do these questions about design and bringing people into design play out in the world of software. And we brought in designers from all sorts of fields. We had type designers and mechanical designers and urban designers, because there was a commonality about the attitude, about the posture to designing, which wasn't specific to any one of those. And the question was, how does that play out in software? More recently, the design focus that I've had is due to connections with this fellow. Now we're out of the gray hair business, right? A lot of you know David Kelly. He's here in the mechanical engineering department and was a founder of the IDEO design firm that's the best known, probably most successful general product design consultancy, if you want to call it that, here in Palo Alto. And he and I started teaching a course together many years ago in which we got together small teams of students, which included his students from mechanical design and my students from CS, and put them to work on simple projects where you needed to bring both of those together to build something that would really be useful. that would work for people, and train them in things like human-centered design. The way that he talks about, I'll talk about the D school in a minute, but the way that we posture this is that students should be T-shaped in their skills. That is, depth, and that's that list I just put up for all of those other things, is what places like Stanford are really great at. I know I can look out into a room here and see people who understand computer science cold. They've taken the courses, they know the stuff, they can do it well. And similarly, I can find people in anthropology or in business, whatever it is. What isn't part of the normal university curriculum is understanding how those fit together to make real things happen. Now, I say that a little bit, from the past. I think that's becoming more the norm. I could argue that's because of things like the D School, but certainly the classical academic norm is you get your benefits by really being the best, the deepest in what you're in, not by understanding and making it work with other things. So what the D School does, and what the courses that I'm involved with do, is to say, how do you get students to learn about design in this integrative sense? And the first principle is you learn by doing, not by talking. So you don't give a bunch of lectures, right? You can have a lecture now and then, but you basically get people out there trying to solve problems which inherently require multiple perspectives. You can't just pick one from my earlier list and say that's the one, right? You have to say this and this and this are all things that matter. And then you try. You don't just sit back and think about it and come up with papers about it. You actually go out in the world, build things, prototype them, see what happens, go back around. Sometimes it works, sometimes it doesn't. That's true of industry too, right? But the basic idea is to use that kind of integrative project as a way to get people to cross the bar in the T. The particular project I've been working on for the past few years, we apply simple cell phone-based technologies in Nairobi. We actually go over there. I've been there a number of times. We take students over for a couple of weeks. They talk to people, work closely with students from the university there. Here, I think I have a picture. So this is a mixture of our students and University of Nairobi students and faculty. So the two guys, tall guys there is Josh Cohen, who teaches here with me, and Dan Orwa, who's in the computer science faculty there. So we work with the department there, also very closely with local NGOs, organizations that are actually doing sanitation or doing health or doing what they're doing. Because part of the principle, of course, is you can't design in a vacuum. You can't say, this seems like a good idea to me. Why don't they want to use it? I mean, you can. People do that, but you shouldn't, right? So you have to understand how do you go about actually taking advantage of these kinds of connections to learn. And that's when you say, what is design? I think it's that insight about how you integrate other people and knowing what they want. This is a particular project which just last night there was an event at the med school where they had a poster on it, trying to help people find clean drinking water in the slums, where there's a small number of water taps that are sometimes open, sometimes not, sometimes clean, sometimes not, and using a very simple cell phone exchange information mechanism so that instead of walking around for hours with these cans, you hopefully can go directly to the place that actually has what you need. Okay, what does this all, and again, if you remember I gave this talk at the CHI conference to start with, have to do with the kind of research you might do as a CHI researcher? Well, one answer is technologies. And although I come from this sort of human-focused, human-centered side, you can't deny that somebody who comes up with a totally new concept for a physical device that displays or senses or whatever is going to be a contribution. And there are a lot of places where the contribution isn't how it all fits into this picture. It's the step back from that. Here's a gizmo. You can try. See what you can do with it. So I think there's still a wide range of fascinating questions in what kinds of physical devices, what kind of technologies are going to shape the next round, just as the iPhone shaped this round, and so on. Another is to do research on these human sciences. So I made that long list, everything from linguistics and anthropology and business and so on. And I think there is room in all of those to say, let's do research about what happens when you bring in technologies. So it's not just general linguistics or general management theory, but what is the overlap between that and the technologies? Interaction mechanisms have been the sort of mainstay of CHI. If you go to the CHI conference, for those of you who still have the option of going and aren't there already, it's in Paris starting this weekend. And great place to go in the springtime. A lot of what you see there is a finer grained, as what, to use Thomas Kuhn, normal science, right? That is, if you have the idea of using a mouse to point to a screen, how can you point better? Right? If you have the idea of typing words on a keyboard, is this thing called swipe going to let you much more quickly do stuff on your phone than if you have to type one key at a time and so on. And that's perfectly valid research. I mean, I think that some people feel, well, that's just a waste of time. It's not the big picture stuff. But it certainly is a valid part of any science to say, let's take the things we basically understand and go deeper. Let's understand exactly how to make them work better, exactly where the parameters are. So that's another realm. The harder part is design. And there's sort of a quandary as to what constitutes design research. Design practice is much more straightforward. So I'll switch the question for that. How do you think about designing your own research? And this is the preachy part, but let me just take a minute to end with this. One answer, which came, and going back to the work I do with Flores and so on, got this fancy word from philosophers called ontology and ontological. It's used in many different ways, but basically what that means is start by thinking about what are the basic underlying issues you're dealing with, not the surface stuff. What is it about? Why is it valuable? Another sort of general thing is always be challenging your assumptions. Right? This is advice to not just young researchers, but all of us. It's very easy to get locked into saying, well, how do I do X better instead of should I be doing X at all? Right? And a lot of the success in the design methods of things like IDEO, they always talk about the fact if somebody comes in and says, can you help us with improve our toaster? They say, well, why do you want to warm bread? Right? And maybe the answer is you have a good answer to that, and you do improve the toaster, but it leads you always want to step back as well as forward. Be open to opportunities. Again, this is so trite, it's useless to say, but I think it's something that people in academic research aren't quite as open to as people who go into business. I'm always impressed by the fact that the people I know who've gone off to start some kind of a startup business often end up doing something which, if you had asked them at the beginning, they would have said, no, that's not what I'm doing. Right? It's called pivoting. Right? If you're in the business school, it says, oh, I got out there. What I realized is this thing I thought I was doing isn't really what's needed, but this one is. And I think in academics, we tend to be more locked in. We write proposals. You have to, all sorts of whole structure, which makes it harder to say, I see a new opportunity here, which isn't what I thought I was doing. And let me go do it. So hopefully we can get some of that spirit into the academics. And then the bottom one, which is from that discussion on meaning, is look for the ways in which what you're doing, whether it's social networks or glasses, whatever it is, fits into the way that people want to lead their lives and what means something to them. Having used up almost all of my time, I will take questions. $47. Yeah.
Terry, there's no microphone.
Actually, we've never used microphones, but
They're above you.
the answer is there are microphones. If you look at the ceiling, you see all these plumb bobs.
No, this is what I want.
No, sorry, go ahead.
This is not a question for Terry, but this is something about Terry. So stories are great things. I just looked, remember that slide of the info bus? Well, part of that big picture is online digital archives. And so this is from the Feigenbaum Digital Archive at the Stanford Library, dated May 5th, 1977. So that means that at least half the people in the room were not born then. Dear Dean Royden, Dean of Humanities and Sciences, with pride and enthusiasm, the Computer Science Department nominates Professor Terry Winograd for your Dean's Award for Distinguished Teaching in Humanities and Sciences. And then it lists a whole bunch of reasons, things he did. As you probably have heard through your informal channels, Winograd's brilliance as a lecturer is now well known throughout the university. His courses on computational linguistics are, quote, star attractions, unquote, and his seminars on advanced technical issues are usually filled to overflowing. In addition, he is much sought after as a program and thesis advisor by our students. He carries a much heavier advising load than the average faculty member in our department. Two of his graduate thesis students will graduate this year, et cetera, et cetera. It goes on like that, but I just thought you'd like to hear that.
Thank you. And for those who don't know, while we're in history mode, Ed Feigenbaum was, among other things, I mean, a couple of points, really one of the founders of the artificial intelligence program guidance here, and the person who invited me to come. So, yeah.
Chairman Shea from Edinburgh, that was an absolutely fabulous talk. I mean, nearly all the advances seem to be experimental engineering rather than theory-driven. Do you think there is some point in the future? I mean, people like Don have done wonderful work. I don't know, but when listening to all the nice examples, I mean, they had real elements of serendipity or opportunism. Do you think there is some point in the future where computer-human interaction will have a genuine theoretical base?
So,
that's not a 2-minute question or even a 0-minute question. But let me say a word about theory. I mean, theory is one of those loaded words that means very different things to different people. Go over to the comparative literature department here and ask them what they call theory. And you will not get something that you would be happy with if you went to the chemistry department, right? So there's a version of theory which is a kind of predictive, quantifiable theory, which is what the hard sciences have developed and used over the years, which says if you have the right theory, you can predict. So in the case of a computer, you might say, this interface will work and that one won't. And we can give you logical, theoretical reasons why not. That approach was pushed very hard by Newell, Simon, Card, Moran, I mean, a whole bunch of people back focused at PARC, but not just at PARC. 30 years ago, is that the right amount? Something on that schedule. And I think it had limited but interesting results. I mean, if you say, has that had a big influence? Not really, but it's still around. I look at theory as including what I call orienting theories. So an orienting theory is not something that gives you answers, it gives you questions. So you say, if I take this theoretical stance, it's going to make me ask about something. And when I ask about that, that may guide what I try in experimental engineering. And so things like the whole philosophy, hermeneutics, I mean, the stuff that I wrote on Flores and so on, I would say falls in that kind of theory. And I would say the humanities people think more that way. The theory is a framework that leads you in certain directions. It isn't a mechanism that you can crank to get answers out. And my own view is that the theories that are going to continue to have value primarily are more of that kind than of the, mechanical engineering physics kind, which tells you this bridge is going to collapse if the stress is more than 0.3, and so on.
That's the way to think about what Darwin wrote.
yeah. Right. Intelligent design isn't a theory. It is. I mean, it is a theory. I mean, that's the point. Is that the way you're oriented actually leads you to ask different questions. Yeah.
So then many of the theoretical perspectives you're proposing were not sort of from our own academic pedigree in a sense. We drew on them, and I think to our own strength that we did so. And yet I feel like we often critique ourselves as being somewhat atheoretical as a result. Do you think that we should be pushing harder on creating those kinds of theories that we can use to build up our own future work? Or is this something where we'll continue to get more leverage out of drawing on others?
I think my sense
is that the leverage is in shifting and transforming rather than creating separately. So if you say, what are the kinds of theories, take the obvious example, what are the kind of theories that sociologists try to make about social behavior? Those are tremendously affected by the fact that we have social networks because they have creates different phenomena. Those phenomena call for different kinds of explanations. The theories themselves may end up being social theories. They aren't HCI theories. But the whole point of what those theories are about is part of what we're creating. Yeah, Bob.
Here's your invitation to speculate about the future of HCI in 10 years, 20 years.
and you can answer it in any way you choose.
Well, I think 10 years or 20 years is, we're not talking 100. If you said 100, I would say brain interfaces, whatever, who knows? I don't really know. The obvious trends are going to continue. So the notion that a computing device includes what's in my pocket, and it includes what's strapped to my wrist, and it includes what's in my heart monitor, and so on, is going to grow and grow and grow. We'll no longer, and this is again something Weiser said 30 years ago, we'll no longer think of a computer as this thing you go up to. It's just part of the world. It's part of the environment where they're ubiquitous, invisible. So that's going to happen. Along with that, there will be a lot of applications which require interfaces that are, for example, integrating that information. I think the whole, quote, big data world, the nice thing about big data is you can calculate all sorts of things. The problem with it is, one of the problems is that it's, oops, when you close this, it doesn't actually go off. That is very hard to make use of. It's very hard to make sense of. So I think this whole world of sense making, to put in that, and it includes things like visualization and graphics, which Jeff Hare works on. It includes things like having ways to trigger awareness of events other than just somebody says do this now. I think there's a bunch of things in, again, dealing with, let me call it attention and awareness. We all agree there's plenty of information. That's not a problem. The problem is attention. How do we focus that? How do we manage it? There's a whole set of issues going back to this social political side that I think are going to come up and be very interesting and problematic for research around things like privacy. And you see it happening now with the Google Glass, right? There's this cool thing, and I can wear it, and I can go around, and I can display the weather and who you are and whatever it is. I can also take pictures of everything I see. This whole recent thing in Boston was an example where there's a benefit to the fact you can take pictures of everything you see, but there's a flip side, there's a downside. And I think a lot of the stuff that's going on in social networks as well as things like ubiquitous devices, at some point we're going to get a couple of serious, that shouldn't have happened. And then that will cause rethinking and new research on how do you get the benefits without having that happen. Yeah.
One question I think related to theory and related also to the future is what's driving the progress, the H, the C, or the I? And I think for the early part of the work, it was clear the technologies or the computers were driving it. I see your work as trying to put the emphasis on the I and making progress that way. So you might be dreaming about technologies that don't exist and thinking about the human and how it might go. So could you say something about that and kind of what are the drivers for progress?
I'm focused on the H myself, right? I mean, I think, as I say, technology is going to progress. There's no way that what we have physically as technologies is the end limit. It may saturate in a sense. I mean, there are a certain number of form factors that work with people, going back to Dreyfus, and other form factors are just useless if they don't integrate with people. But organic displays and flexible this and all that kind of stuff. You never know. Some particular new technology in those could drive a whole new field, but I'm not sure of that. Interaction, I guess I was putting in there as a way of talking about how people relate to it other than the human-centered design. So in some sense, I'm being unfair by distinguishing interaction and design and giving interaction all the dull stuff. So I would say it's the human-centered design side. What are the things people want to do and how do you support those?